Okay, so for today's lesson, we are going to look at identifying integers and their opposites. So by the end of this lesson, you will be able to identify and graph a given integer and its opposite. Before we get started though, let's review a couple of key points that we've already gone over in the past. These skills that I'm going to talk about are skills that you already know how to do, but you will need to use during this lesson. The first one is comparing whole numbers, looking for similarities, looking to see if they are greater than, less than, or equal to. Then ordering whole numbers, putting them in order from least to greatest or greatest to least based on the attributes of the number. And finally, locating numbers on a number line. So we're going to be doing that today, and we're going to go over these skills in just a moment. When we're talking about comparing whole numbers, we're going to look at these two sets of numbers here. In this first set, we're going to be comparing the digit in the thousands place. So this number, 3,564 and 3,528. The digit in the thousands place on these two numbers is 3. Therefore, these two given numbers are equal to based on the thousands digit. In the next set of numbers, we're looking at 3,564 and 3,528 once again, but this time we are going to compare the digits in the tens place. In the first set, we see that the tens digit is a 6. In the second number, the tens digit is a 2. Therefore, this number is greater than this number based on the tens digit. So 3,564 is greater than 3,528. That is an example of comparing whole numbers, which we've gone over before. So let's look at ordering whole numbers. Now when I say ordering whole numbers, that's when we're talking about ordering numbers greatest to least or least to greatest. So in this case, we're going to be working with the numbers 356, 348, 59, and 416. Out of this series of numbers, we're going to identify the greatest number. And in this case, that would be 416. Now we're going to look at 356, the same sequence of numbers, 348, 59, and 416. So we've already used 416, so now we're going to look for the next greatest number. In this case, it's going to be 356. So let's look at these set again, but this time we're going to look for the next greatest number. So we've got 416 and 356, so the next greatest number is going to be 348. And finally, we're looking at the least number in this series, which I'm sure you can tell already, but in case you cannot, it's going to be 59. So now we've identified the greatest number in the first sequence, the next greatest in the second sequence, the next greatest in the third sequence, and finally the least in the fourth sequence. So what we're going to do now is we're going to order these numbers, greatest to least. So in order to do that, we're going to have 416 is greater than 356, which is greater than 348, which is greater than 59. So we see that we go from the largest number to the smallest number, ordering them from greatest to least. So the next aspect we're going to look at is locating a number on a number line. Just a moment. I'm going to put 0 right in the middle. And then we're going to go 1, 2, 3, 4, 5. And then to the left, we're going to go 1, 2, 3, 4, 5. Notice these numbers have a negative sign. We're going to go over that in just a few moments. So I want you to plot, we're going to plot, in this case, or graph, positive 4. So we're going to start at 0 and move 4 units to the right. 1, 2, 3, 4. And we're going to graph our point here. Now, we're going to move, and we're going to graph negative 4. So now we're going to start at 0, but this time we're going to move 4 units to the left. 1, 2, 3, 4. And we're going to plot our point. And we arrive at negative 4. Tomorrow I want you guys to be going over, we're going to make a foldable in class to help you remember some key terms, but I'm going to go over some of those real quick, just so you can understand what we're going to talk about here in just a moment. The first term that we're going to go over is integer. Integers are the set of numbers, or the set of all whole numbers and their opposites. So what are the opposites? Well, opposites are defined as two numbers that are the same distance from 0 but they're on different sides of 0. So if integers are the set of all whole numbers and their opposites, and then opposites are two numbers that are the same distance from 0, but they're on different sides of 0, in the previous example, negative 4 and positive 4 would be considered opposites. Let's go ahead and work a quick example of using integers in a real-world setting. So I want you guys to consider elevation. Elevation is the measurement of a location based on its distance from sea level, and sea level is considered 0. 0 feet is sea level. So elevation can be above sea level, which would be, a mountain or what have you. And elevation can also be below sea level, a valley, a low-lying place. So let me make a table real quick. Wait just a moment. We're going to be looking at some various locations and their elevations, which are measured in feet. Okay? So the first place that we're going to look at is called Little Butte. Which will be marked with point A. And it is at 5 feet above sea level. And remember, sea level is 0 feet. Okay, then we're going to look at Cradle Creek, which we represented by point B, and it is at 5 feet below sea level. Notice it's negative number, -5 means it's below 0, so it's below sea level. Now we have Dinosaur Valley, which we represented by point C, and it is at 9 feet below sea level. And then we have Beaver Creek. Oops, I spelled that wrong. Give me just a moment. No, that's right, sorry. Disregard. Which we marked by plot D, and it is going to be located at 3 feet above sea level. Okay, so now we're going to graph these points A, B, C, and D on a number line. So let me make the number line just a moment. Okay, so now let's graph point A. Point A is 5 feet above sea level. So this is a positive number, so it's going to be above 0. So we're going to count 5 units to the right. 1, 2, 3, 4, 5. So we're going to mark 5, and we're going to label that point A to indicate Little Butte. Then we're going to mark Cradle Creek. Now Cradle Creek is 5 feet below sea level. So we're going to start at 0 and move 5 units to the left. 1, 2, 3, 4, 5. And we're going to mark our unit there, and it'll be point B. The next location that we have is Dinosaur Valley, and it is 9 feet below sea level. So we're going to count 9 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plot our point, and we're going to label it C. So that would be -9. And finally we have Beaver Creek, represented by the letter D. And it is 3 feet above sea level. So we're going to start at 0, and we're going to count 3 units to the right. 1, 2, 3. And we're going to plot our point and label that D. So based on this graph and this data, I want you to consider which point on the number line represents the measurement for sea level. It would be 0. 0 represents the measurement for sea level. Now, which location is closest to sea level? If this is sea level right here, we have Cradle Creek is 5 feet below sea level, Beaver Creek 3 feet above sea level. We have Little Butte, which is 5 feet above sea level. So we want to know which one's closest to sea level, so that would be the shortest distance away from 0. And that in this case would be point D, Beaver Creek. Now, which 2 locations are the same distance from sea level? We have Little Butte at 5 feet above sea level, which is 5 units from 0. And then we have Cradle Creek, which is at -5, or 5 feet below sea level, which is also 5 units away from sea level, which is 0. So the 2 points that are the same distance from sea level would be Little Butte and Cradle Creek. So at this point, I want you to consider which location has the lowest sea level. And it's not just the value of the number that we have to consider, but we want to know the lowest sea level is going to be the farthest below 0, the farthest below sea level. And in this case, point C, which is Dinosaur Valley, at 9 feet below sea level, is going to be the furthest or lowest point from sea level. So now we're going to take a look at some opposite numbers. Oops. Let me replace some of these marks on my graph. Back here. Okay, I'm going to erase this information here. Now we're going to consider identifying some opposite numbers. We discussed opposite numbers in the beginning, and we said opposites are any two numbers that have the same distance from 0, but are on the opposite sides or different sides from 0. So if you have a number line on a piece of paper, you can fold it right down the middle, right over 0. And all the numbers on this side have opposites on this side. They're the same distance away. So positive 1's opposite is -1. Positive 2's opposite is -2. Just the same with positive 5 and -5, as we discussed earlier. So let's take an example here. I would like to graph the numbers 7, so I'm going to go 7, -6, and 1. So I'm going to start with 7. I'm going to do 7, -6, and 1. So I'm going to plot them. So we're going to start with 7. We're going to move 7 units to the right. 1, 2, 3, 4, 5, 6, 7. There's 7. Now I'm going to plot 6, -6. This time I'm going to move 6 units to the left. Starting from 0, 1, 2, 3, 4, 5, 6. So that is -6. And the last I'm going to measure here, or I'm going to graph here, is positive 1. Starting from 0, that's 1 unit to the right, and we have positive 1. So now we're going to identify the opposites of each of these integers on the number line. So, in order to find the opposite of 7, we know that it's going to be 7 units away from 0, but it has to be on the other side of 0. So starting from 0, we're going to go 1, 2, 3, 4, 5, 6, 7 units to the left. And so this would be -7. So -7 and positive 7 are opposites. Let's take a look at -6. We know that -6 is 6 units to the left of 0. So in order to find the opposite, we have to look to the other side of 0. And we're going to go the same distance of spaces. 1, 2, 3, 4, 5, 6. So here we have 6. So the opposite of -6 is positive 6. Are you seeing a pattern here? Let's look at 1. Here is positive 1. So the opposite has to be the same distance away from 0, but on the other side. So let's take a look here. We go 1 unit to the left, and we find -1. So each of these integers has an opposite on the other side of the 0. So at this point, we're going to go ahead and conclude the video lesson. When you guys come into class tomorrow, we're going to be working on a couple of activities. One will have to do with temperature and recording climate changes or degree measurements from different periods of time. We're going to graph those and locate them on the number line. And we're also going to look at an example based on the measurement of distance. And we're going to find various distances and plot those on the number line as well. So hopefully you guys will write down any questions you might have for me. We can discuss those tomorrow. And I hope you're ready for the activity, and I'll see you then. Thank you for listening.